So today we're going to learn a new subtopic or a new distribution which is called Poisson Distribution. At the end of this lecture, you should be able to identify the Poisson distribution. Okay. X has Poisson distribution with lambda or mean. Okay. Determine the probability of an event. Determine the mean and variance for Poisson distributions. Poisson distribution. Identify the Poisson distribution. Poisson distribution, a few characteristics, a bit different from binomial. Okay, the number of occurrences in a particular time interval or space interval. Don't think too far. It is not outer space. It's just space interval. Like kalau kata interval of time means in a period of time, in a month, in a week, in 3 years. Okay. Or if I say space intervals, mean let's say page, a sheet of metal. Okay, that's what it means, space interval. Okay, the occurrences are random. Okay, we're doing probability, so the occurrences must be random. The occurrences are independent of each other, and the mean number of occurrences is the same for each interval. Alright, let's go to how to determine the probability of an event. Okay, we have two, just like binomial. Okay, we're going to use the Poisson formula and Poisson distribution table. The first part, Poisson formula. So, how to read this? Okay, so X has a Poisson distribution with mean. Okay, this Greek word is lambda, which represent the mean. The formula, probability X equals to X. So this Poisson distribution is only for X equals to, or probably X is exactly, the word exactly. So X is the number of occurrences, exponent, okay, the value for exponent. We're not going to use this value, we just have to press the calculator, okay? To the power of negative lambda or negative mean, okay? Lambda is the mean number of occurrences in a given interval times with lambda to the power of x divide with x factorial. We're going to use this, okay? I hope you know where these symbols in your calculator. Our x starts with 0, 1, 2 until. If binomial, we have until n, number of trials. Until when? Infinity, countless. If x has Poisson distribution with mean 6 or lambda 6, find the probability by using the Poisson formula. So our lambda here, or the mean 6, probability of x equals to 3, we just have to substitute. Exponent, negative 6 because negative lambda, okay, times with 6 to the power of 3, divide with 3 factorial. So you need to memorize the formula. It is only for x equals to x, okay? Exponent, negative lambda, lambda to the power of x divide with x factorial. How to press this calculator? I'm going to use shift, so shift ln. I'm going to get exponent to the power of negative 6, okay, times with 6 to the power of 3 divide with 3 factorial. Where is the factorial, people? Here, right? X to the power of negative 1. There is the yellow fonts there, x factorial. Did you find it? On top of your x to the power of negative 1. Is our calculator same? Yes, okay. So, shift x to the power of negative 1. Did you find it? Yes. Make sure you know how to press the calculator. This factorial is on the top of x, the button x to the power of -1. So you're going to press the shift and this button. So 3 factorial, so you're going to get 0.08923507836. That is too long. Just 4 decimal places, okay? 0.0892. Next one. Probability of x less than 2. Okay, so our Poisson distribution start with what? X equals to 0. Very good. Okay, so less than 2 is also means probability of x less than equals to 1. So we're just going to do start with probability of x equals to 0 plus probability of x equals to 1, and we're going to substitute into the formula. So you're going to substitute exponent -6 times with 6 power 0 over 0 factorials. 6 power 0 is 1, 0 factorials is not 0, 0 factorials the value is 1. Plus with exponent -6 times with 6 to the power of 1 divided 1 factorial. -6 plus with exponent -6 times 6 divide with 1 factorial. Do I have to do this 1 factorial? Well, okay. So we're going to get this value. Okay. So you should get the same thing. Yes. Okay. Let's round off to 4 decimal places. So we're going to get 0.0174. Probability of x greater than or equals to 2. Where should we start? X greater than equals to 2. X equals to 2 plus what? X equals to 3. Some more? Until infinity? Impossible. We're going to do that. Until when? Impossible, right? So what we're going to do is we're going to do the opposite or the complements. Okay? So we're going to write down 1 minus less than or equals to 1, right? Okay, what is the probability of x less than or equals to 1? From the previous question, 0.0174. So you're going to get 0.9826. Probability x is greater than or equals to 3 and x less than or equals to 5. 3 is not included, okay? So what we want is x equals to 4 and x equals to 5, okay? So substitute into the formula, okay? Exponent -6 times 6 to the power 4 divided with 4 factorial plus with exponent -6 times with 6 to the power 5 divided with 5 factorial. So substitute into your calculator. Do not find each of the formula, the value for each of the formula. You find this value, then you plus with this value. Don't do like that. Okay? Put every single thing into your calculator. So you're going to get 0.2945. Now, let's find the probability using Poisson distribution table. Okay? So for your table, you're going to use for probability of x greater than or equals to x, same as binomial, and your maximum lambda is 30. If it's 31, not in the table. Use formula. So look at your table here, right? Table have 2 sides. Your left side, for the and also right side. Okay, this is the right side. Okay. You have the same values for the first column, right? For the first, it is for the mean, okay? The maximum I said is 30. The value of R here on your left and right. So if I have probability of x greater than or equals to 3, okay, you only can find for x greater than or equals to. I have a Poisson distribution where the lambda, let's say 0.6. Okay, the mean is 0.6. So first thing first, you're going to do is find this lambda or the mean 0.6. Where is it? Okay, so the lambda 0.6 is here. greater than or equals to 3. So it stands for the R. Probability of x greater than or equals to 3. 0.0231. Okay? As easy as that. Okay? Alright, now we have if x has Poisson distribution with the mean 5.5. Okay, so find in your table, okay, where is your lambda or your mean 5.5. Find what is the probability of x greater than or equals to 5. Okay, where is 5.5? X greater than equals to 5. X greater than equals to 5. Here, find it on the same time. 0.6425. Did you find it? Find probability of x less than or equals to 5. Does our table can find this value? No. 1 minus. So what is the number after 5? 6. This is 5.5. X greater than or equals to 6 here. 0.4711. So 1 minus 0.4711 is 0.5289. Probability of x equals to 5. Probability x greater than or equals to 5 will minus with the number after 5 is 6. Probability of x greater than or equal to 6. We find these two values already. 0.6425 will minus with 0.4711. So minus these two values, we're going to get 0.1714. Probability of x is greater than or equals to 3 and x is less than 8. Probability minus with probability of x greater than or equals to 8. To make things easier, make both equals. Less than or equals to, less than or equals to. What is the number before 8? 7. So, bila nak tolak, we'll minus with the number after 7, which is 8. And probability of x greater than or equals to 8 is 0.1905. 0.7211. If you still don't understand, let's draw some number line. Okay, 3 sampai apa yang dia nak. Sebelum 8 apa? 8 is not included, which is 7. Okay, we want this value. Alright, so what we're going to do is we're going to take greater than or equals to 3, then we will minus with the number after 7, which is 8. Once we do that, okay, probability of x greater than or equals to 3 minus with probability of x greater than or equals to 8, we're going to get what we want. Okay, the probability of x is greater than or equals to 3 and x less than or equals to 7. Let's solve the problems. An average of 3 cars arrive at a highway toll gate every minute. If this rate approximately Poisson distribution, what is the probability that 5 cars will arrive in 1 minute? So to know that which this is Poisson is by looking at the time interval here, and there is word average. Another word for mean. Okay? The word rate, I saw rate just now. Okay, this is also means mean, the same meaning. So if you can't find the word means there, okay, there is a word average and rate. It has the same meaning as mean. What is our random variable? Same as binomial distribution, we need to name our random variables. But for Poisson distribution, the number change according to the interval. Okay, so you need to name together with your time interval. So our x is the number of cars arrived in 1 minute. So what is the mean? 3 is for 1 minute. Every minute means 1 minute. So x has Poisson distribution with mean 3. So the question asks, what is the probability that exactly 5 cars? Probability of x equals to 5. Press the calculator, then you're going to get 0.1008. Table. Can. Okay. X greater than? Tolak dengan siapa? 6. Now, what? What is the probability that exactly 7 cars will arrive in 5 minutes? We have a new mean now, which is 15. Okay? Our mean change. When our mean change means our random variable will also change. So you need to rename your random variable. Just now, the first question, in 1 minute. Now, the mean change, okay? Our random variables will also change because now it's 5 minutes, okay? Write down the new parameter, okay? So x has Poisson distribution with mean 15. So this one just put into formula, okay? 7 cars, okay? 7 cars. So you're going to get 0.0104. In a library, the mean number of students borrowing books between 8 p.m. to 8:40 p.m. is 8. Using the word mean here, which is reserved for 8, okay? The mean is 8. Find the probability that 4 to 6 students borrow books between 8 p.m. and 8:40 p.m. Name your variables. So this is about the number of students who borrow books between 8 p.m. to 8:40 p.m. Panjangnya. Well, good luck, okay? What is your distribution? So x has Poisson distribution with mean 8. This mean is for between 8 to 8:40 p.m. What is the question? 4 to 6. 4 to 6. How to represent inequalities? 4 to 6. What happened to the sign of the inequalities? Probability. X is greater than or equals to 4. Okay? And x is less than or equal to 6. Both have less than or equal to sign. So what we're going to do is, okay, using the table, property of x greater than or equals to 4 will minus with property of x greater than or equals to 7. This is 8, 4, 0.9576. Another number, x greater than or equals to what? 7, 0.6866. So minus that too. Okay. Then what you're going to get? 0.2710. No student borrow books in first 5 minutes. 40 minutes, the mean is 8. Now what? 5 minutes. So 5 minutes, what is the lambda? You may do like this. 1. If it's 1 minute, 0.2. So kalau 5 minutes, so 5 will times 0.2, you're going to get 1 also. Okay? So, or you may write down as 0.2 times 5, okay, which is also 1. So, x is the number of students borrowing books in the first 5 minutes. X has Poisson distribution with mean 1. No students means what? Probability. X equals to 0. Okay? So, put into the formula, okay, exponent negative 1 times 1 to the power of 0 divided with 0 factorial. You're going to get 0.3679. Find the probability that at least one student borrow books in the first 15 minutes. First 15 minutes. So your x is the number of students borrowing books in the first 15 minutes. What is your new mean now? How many students in 5 minutes? 1, right? Okay. So kalau 15 minutes? 3. Okay, so the new mean is 3. So x has Poisson distribution with mean 3. What's the question? Probability at least one student. So you can take a look from your table. The mean is 3 and your r or your x is 1. Probability of at least 1. What's the value? 0.9502. Just write down. Okay. Determine the mean and variance. If x has Poisson distribution with the mean, okay, mean or the Greek alphabet mu is also lambda, okay. Variance, you may use the word var x, okay, or the Greek word sigma square is also mean. These two are same for Poisson distribution, okay? But for standard deviation, you have to square root this, okay? You have to square root the lambda, okay? So find the mean, variance, and standard deviation if x has Poisson distribution with lambda or mean 1.8. So find the mean is 1.8. The variance also 1.8. Standard deviation, all you have to do is square roots of 1.8, okay, which is 1.342.